Hi everyone, welcome to my channel. This is Leo and let's do some more LeetCode problems today. Today's problem is called longest consecutive sequence. We were given an unsorted array of integers and we're going to return the length of the longest consecutive element sequence. By that, we see the longest consecutive elements sequence. Okay. And you must write an algorithm that runs in O(n) time, but we can safely ignore this at this time because we're going to optimize along the way. Okay, let's take a look at an example to understand what this really means. We were given an input array with this, and the output is 4 because we see 1, 2, 3, 4, the sequence here. So that's the longest consecutive elements sequence. Okay. Therefore, the output should be 4. And here, if we have this one, the longest consecutive elements sequence will be 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that should be 9. And here, this one, we have 0, 1, 2. So the longest sequence will be 3. Okay, so intuitively, if we ignore this, what should we do? We should sort the input array and start from the leftmost number and see if its next number is here. If it is, we can increase the current streak and update the when it changes, we can update the maximum streak. Okay, so if not, let's say if we have 1, 2, 3, 4, okay, and the current streak is 4. Okay, let me write it down here. So after sorting, we have 1, 2, 3, 4, 100, and 200, and we start counting from here. So the current length is 1. Okay, 1, and here we have 2. The current length is 2, 3, and 4, and here we don't have 5. So we should start over. So the current is 1. And the next is also not 1 and 1. Okay. So we reset the current to 1 here. Okay. And along the way, we will have a maximum and we can update it. So here is 1, 2, 3, 4, 4, and 4. Okay, so the maximum will be 4. And let's code it out, and then we see how we can optimize it to O(n) time. Okay, so let's do some sanity check first. If nums equals to null or nums.length equals to 0, we'll return 0 because we don't have any streak like that. Okay, so now we can sort the array. Sort the input array, and we have a cur equals to 1, we have a max equals to 1, okay? And next, we will iterate, we'll iterate the array from the second element because we have to understand the relationship between the first element and the second element to see if they are consecutive, okay? So here, and if nums I doesn't equal to nums I minus 1, okay, so that means we have a different elements in the first two, okay, if they're different. If nums I equals to nums I minus 1 plus 1, that means they are consecutive. We will increase our current streak, okay. If not, we will update the max, okay? And we will reset cur to 1. Okay, that's what we will do to check for two elements, okay? And if they're the same, we will just continue, okay? And after that, we can just return the maximum, okay? But I think for our logic, let's see if it works. So we have 1, 1 here, and the first two elements are not the same. And they are consecutive, so we increase the current. And here, this logic doesn't stay, so we will update the max and reset the current to 1. Okay, and otherwise, if they're the same, we will just continue because we're not dealing with duplicates here. Okay, so I think this should work, but I come to think of a corner case that should be addressed, which is 1, 2, 3, 4, 5. Okay, so if we use the same logic, the current will be 1, 2, 3, 4, 5. And it will not go into this else statement. So we didn't update our max at all. Okay, so our max will remain 1 along the way, which is not right. Okay, so for this, I will update it at the return statement. So math.max, max incur. Okay, this should give us the right answer. Okay, yeah, looks all right. Okay, so let's analyze the complexity for this solution. It's sorting, so the time complexity should be n log n, and since I'm using Java, I believe it is quicksort, so the space complexity will be log n because we have a stack for the quicksort. Okay, so let's submit it. Okay, perfect. It goes pretty well. Okay, now let's think about this one. Can we optimize it to O(n) time? So I think the biggest problem is we cannot check whether the consecutive number is in this array without sorting it. Okay, but if we could look it up in something in O(1) time, and every time we will check it, then we can see update the current streak. Okay, so I think of something different here. Maybe we can put it into a set, which give us a O(1) lookup time, set of integer has set, and I will put all the numbers in the nums array into the set. Okay, so now I have this set. I have 104, 200, 132. Okay, and after that, I can check on the numbers here. So I will only update the max. Okay, for all the numbers in our set, I will check from the first one. Okay, so if it doesn't contain the left consecutive number, for example 99 here, we will start from this number. Okay, so I will set current number equals to this number, and I will set the current streak to 1. Okay, if it doesn't contain. So starting from this means we have to look for 101. Okay, so while this condition exists, while set contains current number plus 1, we will keep updating the current streak. Okay, okay. Also, we will increase the current number to 101. Okay, if not, we will not do anything. Okay, so after this, we would update the max. Okay, So in this case, we could return the max itself. Okay, let's see. So for this one, set doesn't contain 99. So it should be 1, and we will not go through this logic, so max will be updated to 1, okay? And let's see the second element. It doesn't contain, it contains 3, okay? So we will not process this number. And for this one, doesn't contain, and the string is also 1, okay? So we ignore this. And for 1, it doesn't contain 0, okay? So we start from here. The current is 1, and the set contains the next element, so we will increase it to 2, okay, and then 3, then 4, okay, and then we can update this max, and last we will return the max, okay. So the logic looks good, okay. And for this, we achieved a time complexity of O(n) and a space complexity of O(n) because of the set, okay. Submit it. Okay, perfect. Passes all the test cases. This is a pretty tricky one. So yeah, we use a set to save all the numbers here, and we use the logic to find all the consecutive elements. Okay. Thank you so much for watching. I hope you liked the video, and if you liked the video, please like and subscribe to my channel. I will see you in our next video.